Three students carry out a rates investigation on the reaction between bromine and propanone in the presence of hydrochloric acid. Each student investigates the effect of changing the concentration of one of the reactants, whilst keeping the other concentrations constant. The results are shown below. Explain how the reaction orders can be determined from the student's results and determine the rate equation and rate constant. Firstly, let's look at the order with respect to bromine. So this would be looking at student 1. So what we can see from this graph is that as the concentration of bromine decreases over time, and it's decreasing at a constant gradient or constant rate. So that means that it's going to have a zero order with respect to the concentration of bromine. So we would say with respect to, and then square brackets, Br2. And the reason why, so because it's got a constant rate. We could also say it's got a constant gradient. Both of these are acceptable as this point. Then if we look at student 2, so that would be looking at the order of reaction with respect to CH3CO, CH3. So looking at the graph, we've got initial rate. As that increases, the concentration of CH3CO, CH3 also increases. And so that means we're going to have a first order with respect to the concentration of CH3, CO, CH3. And that is because, the reasoning behind this, we've got a straight line through 0, 0, or through the origin. And it's a directly proportional relationship. So that means as the initial rate increases, the concentration of CH3CO, CH3 will increase by the same amount, or vice versa. Finally, we need to look at student 3, and this will tell us the order of reaction with respect to H+. So what we need to do to determine the order of reaction with respect to H+ is look at where the concentrations of bromine and propanone remain the same, but H+ increases. So, which is what we've got here in experiment 1 and 2. Bromine is increasing by times 1, so it's not increasing at all. And the same can be said with propanone. However, the H+ concentration is doubling, so multiplied by 2. And when this concentration doubles, the initial rate also doubles. So we can comment on the order of reaction with respect to H+, and that order of reaction will be first order. And it's for a similar reason for propanone, and that is because it's a directly proportional relationship. So that means that as the concentration of H+ doubles, the rate doubles. So we can say square brackets H+ multiplied by 2 equals initial rate multiplied by 2. And this is a way of saying that they're directly proportional to one another. Now we need to write our rate equation and determine the rate constant because we've worked out our reaction orders. So the rate equation would be rate equals K square brackets CH3CO CH3, and that's to the power of 1, and then multiplied by H+ to the power of 1. But we don't need to write these powers of 1, but that just means that they're first order. We could also have the Br2 to the power of 0, but anything to the power of 0 is 1, so we again don't write this in our rate equation. But then we want to work out the rate constant. Rate constant is K. If we rearrange this, we would have K equals rate divided by the concentration of CH3CO CH3 multiplied by the concentration of H+. So if we were going to find an actual number, we can use the data from experiment 1. So that would be using the 1.6 moles per decimeter cubed of propanone, 0.2 moles per decimeter cubed of H+, and our 1.25 times 10 to the negative 5 moles per decimeter cubed to the second to the minus 1. So that would be K equals 1.25 times 10 to the negative 5 divided by 1.6 times 0.2. And that equals 3.9 times 10 to the negative 5. Now we need to look at finding units. So the units we would have would be moles per decimeter cubed, and then seconds to the minus 1, divided by moles per decimeter cubed times moles per decimeter cubed. So if we were to simplify this, we would have moles per decimeter cubed seconds to the minus 1 divided by moles squared decimeters to the minus 6. So then what we can do is we can cancel out the moles and the decimeters cubed from the top, and then one of the moles and one of the decimeters cubed from the bottom. And that would make our units moles to the minus 1, decimeters cubed, seconds to the minus 1. The reason why we have a first order reaction and a zero order reaction from the graphs is because for student 1 we've got concentration of bromine and time, and what this graph is showing is a negative gradient, and it's showing that the rate of reaction remains constant because it's a straight line down. So it's a zero order reaction with respect to the concentration of bromine. Then for student 2 we've got initial rate and the concentration of CH3COCH3, and this is a straight line through the origin, so it's a directly proportional relationship. So that means that as rate doubles, concentration doubles, and this is a characteristic of a first order reaction. And in the question, it says that the reaction is taking place in the presence of HCl, which is why we need to find the reaction with respect to the concentration of H+, and that is because there are H+ ions present from the acid, which is why we've also tried to work this out, and that is included in the rate equation. To get the marks for this question, you need most evidence used to determine the correct orders of reaction, and the rate equation and the rate constant. So that would be saying that you have a zero order with respect to bromine, a first order with respect to propanone and H+, and then having your correct rate equation, which is rate equals K concentration of propanone, concentration of H+, and then the rate constant needs to be 3.9 times 10 to the negative 5 moles to the minus 1 decimeters cubed seconds to the minus 1. This gets you your 6 marks for this question.